it is finally here, the day when we start to actually integrate the brake light, reverse light, neon light that's no longer a reverse light into my 350Z. I think I've figured out pretty much how I'm going to do all of it. There's just one final thing that I'm going to need to find, which is where I'm actually going to pull the ACC power from. But otherwise, I think I know what our battle plan is here. Let me just walk you through the plan. So we obviously have a bunch of stuff that we need. We've got those waterproof connectors, which are the same ones that we put onto our project box, wire cutters and wire strippers and the lights themselves, a multimeter, some 30 volt max capacity wire, a couple of these like little switches, which if we look all the way through to my center console, you can see I've got a couple of them there, which are the ones that actually run the neon lights. And then we've also got these T-taps, which are really good for just splicing into existing lines without killing the existing lines. So how is all of this going to go together, and how are we going to end up with it here? So if we take a look at how the bumper is currently, we'll see all these like little holes that have been drilled over it. These are the riv nut mounting holes that I'll be using to actually mount the ducktail spoiler. But the original OEM like little spoiler that you get on this version, the GT, has these two holes here, which usually have plastic mounting points in them to hold the original spoiler on, which means I can utilize this hole, which is why it's got a little rubber bung in it for now. And we can actually, the wires that are going to be inside this ducktail spoiler can be fed through there, which gets us into the boot. From there, we end up underneath all of this, and that's where things are going to get, I think, really clever. The super observant of you might have noticed this. This is where the original windscreen wiper was for the rear, and like most people with a 350Z, this has been deleted. Now, there was a plug in here, and I didn't like that for how I'm doing it with the wrap, so I'm just in the process of sorting a proper like flush there. I'm actually doing it over here on the aerial as well, so this panel is going to need rewrapping. But regardless, that is where the windscreen wiper used to be, which means underneath here, if we take this off, underneath here are all the original wires that used to be connected into the windscreen wiper. The big advantage of that is these wires already run up here into this hose with these grommets and then comes out in the cabin underneath the headliner. So I don't have to worry about getting wires from the cabin to here, because wires that are no longer used, which are pre-rated for the voltage of the car, are already in here. So I can cut these wires and just reuse them at both ends as pre-put-in wires. Also, conveniently, my box thing is going to live around here, so it just ends there already. So this thing is a bundle of 3 wires, a black, a red and a blue. I'm going to assume the black and the red are just power, and the blue is maybe like an on-off signal that is sent to it. I don't know, but we're going to check with the multimeter, because if it is, that's a really good way of getting the VCC power that we need for this. Now, there's a chance that that only comes on when the windscreen wiper comes on, in which case we'll need to get the VCC power from somewhere else, but we could just get that from somewhere in the cabin, splice it to that red line in there somewhere, and then this will become VCC power. The other really convenient thing, when we continue to take off this trim, carefully, obviously, I've had this trim off way too many times, is that we have a third brake light, which means getting the brake light power is pretty easy because it's already here in the boot. So we can just T-tap into that brake light power, and then we've got the brake source for our light. So we're going to have to like unravel all this and find out which one is which, but we've got the brake light. So that's where our kind of like our brake light and eventually our main power will come from. But like I said, there are 3 lines here, and if we've got the brake light coming from here, you might remember our input has 4 inputs. A common ground, which is already in this. We've got a common ground. Also, there's one here anyway. A VCC, like the switched power, the brake light power, and the neon power. So the only other one we need is the neon, because we've got the brake, and one way or the other, we can put the VCC power into that red line. So where does the neon come from? So when I was figuring out how I was going to do my neons, I created this little power block thing in here, which actually runs off a constant power source. So even though my car isn't on, I can turn all these on, and it gives me, it's probably difficult to see in this light, but an interior cabin for this one. And when I go outside, we have the underglow, which again, difficult to see in this light. So the way the neons work is that the fuse box underneath the driver's side has a permanent power, which runs up into that controller, and then that distributes out. So for the neons, it runs down this center console bit, through the block that has the speakers in. And when we get to here, there's a little hole here, and you can see this wire coming out. This wire, which is underneath this boot cover usually, is the power for the control box for my glow kit, which is actually underneath this polystyrene in the boot, because I didn't want to bother going in through the firewall. So my control box is here, and then the neons actually drop down in a vent that's behind the rear bumper instead of the front. So everything's like reversed, but it means all my control stuff's here, and I have that wire, so I can tap that wire, run it around and into one of those 3 wires that runs through that grommet, and that will mean that one of these, probably the blue one, becomes the neon power. I'm just going to turn the power off, and then I'm going to cut these wires so I've got better access to them, because I'm going to have to do it either way. So let's just chop these wires. Then I swear, 3D printer snips are the most useful thing that I own. I use them for everything. Right, okay. Oh, and of course they're bundled together also under that. So let's strip these. Obviously we're going to be careful not to touch the red and the black in particular, just in case they are, you know, switched power. Let's just test again whilst the circuit is off. Yeah, nothing there. Okay, and once more time with the light battery on. Oh yeah, okay, I've got power. So that's good. So when the battery is on, I think I've got 12 volts. Yeah. 12, 13 volts. And what about the blue? So the blue has also got power. So they're both giving me 12 volts. So basically I'm going to want to use the ground as the ground. The red can become the VCC, and the blue will get spliced in the cabin somewhere to no longer be whatever power it is. And then we'll, you know, tape it all up properly and shrink it in the cabin to make sure it doesn't have any problems. But that's great. It means we already have a power source for the lights in here. So that's a great start. So all I really need to do is 2 things. One, like I say, splice this line in the cabin and turn this blue line into the neon lights line, and then put a T-tap in the brake light here in order to turn it into a brake light. Okay, so we'll start with the which is a 14mm. And at this point I have disconnected the car battery. We need to start with this, which means we need to start with the weather strip. God, I've taken these things off so many times now. This piece is easily the biggest pain in the ass. Even clips into like this one on the bottom. Too many clips. Right. 1. 2. So that gives me access. Now is this that loom? Because if this is that loom, then that means it's a lot easier because I can tap it from further down. So yeah, so that loom that disappears into here runs around this side edge, which means I don't have to do anything awkwardly underneath there. I can just route it from like right down here. So the solution is awkwardly in here somewhere, and it runs underneath this. I don't know if I want to take this whole top piece off. It's just a bit of a pain. So let's see if I can splice into it around here. Some bits that are wrapped in various bits of tape. Just being careful not to like grab any lines. I'm hoping there's only one blue one. There is one blue line in the middle here. There. So that is the line I want to use. What we can do is, a bit awkward to turn to camera, is cut this line here and then measure it from that end to this end, measure if there's any resistance, but I'm 99% sure that's where this comes down to. Like I said, the power is off to the car currently, so not too concerned about like getting zapped or anything. The follow-up issue I have is that the testing wires for the multimeter aren't long enough to reach both of these ends, so I just need to extend one of them. Test both ends of this, and I'm just going to do a resistance test from one end to the other. If I get a signal, it means that I'm getting a signal from both ends and that is the correct wire. Yes, I have a signal. I don't know if you can see this on here, but I have a signal, so it's coming through. So there's a resistance between those two ends, which means that is the wire that I'm after. Right, so we're going to just use this cable. It's long enough. Solder those two ends together and then T-tap in at this end. The reason we're soldering one end and T-tapping the other is that end can be disconnected, and then wherever the blue cable routes back to isn't needed anymore. Whereas the other end, I need to just preserve those connections. So this cable down here, I can't just cut it and rewire it because that cable still needs to exist. So we're going to use the T-taps for that. And done. I did painfully drop my box of heat shrinks the other day, so they are completely out of whack. Do this up. Cable successfully extended. I am super anal about noise in the cabin though, and especially rattling wires. I'm just going to make sure this is all kind of like taped up. And once we've got it in position, we'll add a few zip ties around here just to hold everything in place. So T-tap, if you've never seen them before, look like this. They have a variety of colours. Let's go for red. Basically you have this little bit which has a metal connector inside with some couple of sharp like prangs, and that grabs your wire through there, and then when you clamp it shut, that grabs onto the inside core of the wire. Then you can put this end on whatever other wire you want, and then they just slot into the end, and you're basically creating a T-joint, which is why it's called a T-tap. So let's run that roughly to there, give it a little extra bit of length. There we go. Right, so all being well, that means this wire should now have neon lights power to it. The battery is currently off on the cars. I'm going to switch it back on and then we'll run a test. So I just recorded 5 minutes of footage without actually pressing record. Spectacular work, Andy. All I've done is disconnected the brake light and put a T-tap onto the red wire. It has two wires going into it, a red and a black. I'm going to hazard probably a sensible guess that the red one is the live power. And let's just put another T-tap on that. So with that on there, if I just crudely route this round for now, we are going to, you know, put all these properly in place. That should be all four of my connections to this end. So I need to make an end for this using these waterproof ends. We've seen it. If you haven't seen me use these before, there's a breakdown of it in episode, what are we on now, 6? So episode 4 of this. Yeah, and I'm going into the 4 gang here. So I need to create a 4 gang and just make sure I put them in the order of that I've done. So VCC, brake, neon, and then yeah, ground. So let's I'm going to assume that this brake light's fine. The only bit that will be buggered with the brake light will be the terminal end, so I can route this around and you know, tape it down in a few spots and then zip tie it along here, just so then I've got the length the same as all the rest, and we can, you know, safely cut everything and put that terminal end on. Start with a little bit of this stuff. This is, I don't know what the actual term for it is, but I've only ever called it sniper tape. And it is phenomenal at just sticking down everything. Yeah, wrecked it, Steve. Wrecked it. Huh? I am doing the last bit, yeah, just the wiring. Yeah, it's crap, isn't it? Why do I even bother? So I'm just using some of this stuff. It's, I don't know its real name, if it's called sniper tape or not. I've only ever referred to it as sniper tape. I know it's the stuff that literally in the desert people use to like repair rifles. It is like invincible. Yeah. It's a fabric and it tears, but once it's stuck, it is stuck. And it is just really, really adhesive as well. So it's just great for holding down stuff like this in spots where it wants to go. Once we're here, we can join the world of zip ties, which is the better solution, really. this step is kind of vital. If, like me, and you're massively against any kind of cabin noise and vibrations and rattles, because adding loads of extra wires, it's just a recipe for one of them rubbing against something and just rattling. I hate it. Thought I used way too much wire, but turns out I used basically bang on. Right. So that is my collection of wires. And some of my hair that's just got pulled out. So I need to put these into a male connector. There's a female on this end. So it's one of these basically, which is going to go in there. There are a few ways we could test this, but I think the easiest way is just going to be connect up the neons and see if it works. But in order to do that, I have to extend these out because these don't currently go where they're supposed to go. So this is the one last problem, is that the neons, the normal clip that comes with a set of NeoPixel strips looks like this. And it's actually really useful because it does mean I can disconnect this, which means I can put this connector into the ducktail spoiler itself. So if I want to remove the ducktail spoiler, I can lift it up, use a little bit of slack, and then disconnect this and remove this inside the ducktail spoiler. So that's actually going to be really useful. But what I want to do is go from here and then out the boot. So I just need to figure out which way around I need to do this. So really it's just a matter of extending these through the hole in the boot that we spoke about, so this little rubber bung hole on the top, and then finding a way out of one of the holes on the bottom. This is going to be a little bit fiddly, but we'll do it. It might be easier just to go the other way. Just poke them up and then grab them from the top. And then once we've got them through to here, put another connector on the end and then just pop it all together. So there's a little hole here. Okay, well, one straight through, almost. Where are them pliers? I need something to grab through a tiny little hole. Okay, so there's the power ones, and there's the data one. That's how those are going to route out, and that's how they end up in the ducktail spoiler. So now I need to pop the connectors on this end, much like we've just done. Again, just need to make sure I connect this up the right way round. So where's male 3? There we go, a male 3. So I need to have data in the middle, ground on the left, power on the right. So let's start with the ground on the left. Yeah, so I've got 3 connections in here, which means now I have power and ground and data coming out of the top. So I want to give this like a bit of slack, like I said, because if I'm taking off the bumper, I need to be able to remove it. But because of where it's going to be, I don't want to put a connector on the end, and because it's going to connect to the thing that I've put down and subsequently immediately lost. Where'd you go? There we are. I need to connect to this thing, so we're just going to solder all these wires together and do like a permanent connection, and then just do a heat shrink around everything just to make sure it's nice and secure. Soldering iron in the boot of my car is not my idea of a good time, but needs must. It's nice to have something to do whilst our solder heats up. Big red heat shrink. Power can have the red. Ground can have the black. And data blue. Bit of a tricky way of doing this, but gets the job done. Okay, that's that one soldered. What would I give to have my little helping hands back right now? And then finally, power to power. All being well, this is the last connection. Oh damn. Okay. Immediately get this away from the car. And then give it a sec to cool down, because otherwise when you try and move the big heat shrink down, it gets some of the heat and shrinks at the end. There we go. And then the big heat shrink. I dare say we've done it. Now if I put my box in place and I connect this up to the lights, it should all start up. Right, I guess we best test it. Connect this here. And then this one to here. And then I'm just going to shut this in the boot. Oh, I need my lights. Bye bye. And then we'll connect this up here. So if I've done everything correctly, when I turn the car on, this goes red. It has not gone red. Why? Okay. What happens if I press the brake? Nothing? No. Of course it wasn't going to be that easy. So now comes the question, where's it gone wrong? It is 2 and a bit hours later, and it is not fixed. And the reason it is not fixed is because of my little now exploded bundle of wiry fun. I've spent a fair bit of time like tracing all where the issues could be. All of this up to here and the power coming through into here is fine. But I originally thought that maybe those distributors for the power and the ground that I made were, you know, not distributing properly, so it was losing power or ground somewhere, but it wasn't that. And then I was wondering where else it could be, so I started testing all the various contact points with a multimeter, and all the way up to the terminal that goes into the ESP32. These terminal blocks, if I test the top of them, is 5 volts. But when I test the terminal blocks actually on the ESP32, it drops down to less than 1. So somewhere on this trace that I can't see any issues with, it's losing 80% of the voltage. And I can't tell why it's bleeding out. So there's a big old problem with this. Which is kind of convenient in a way, because I spent all of yesterday learning PCB design and have actually fully redesigned this as a custom PCB, which works as a, I think it's called a header or a socket. I'm not sure which way around it is yet. I'm still working on learning PCB design. And the basically the ESP32 drops straight into the top of this PCB that I've designed, and all the terminals and stuff are in there. So instead of having all of this wiring, it's just wire inputs and output. So it should have much fewer issues. So it's kind of a success in the fact that all of the power and stuff that I've wired up from the car to this point, to this connector, that's all working. And all this stuff at this end that connects out to the lights is fine. It's just my little middle bit. The important bit in the middle isn't working. I think it's not robust enough, basically. So that's why, I guess that's why custom PCB design works. So I'm going to have to just stop for now and say success, and this is how we're in wiring it all and getting at least the preparation wires ready to connect this thing together, but fail in actually getting the lights to turn on, which is a shame, but it's okay. I actually ordered the PCB yesterday, so it should take like a week or something, and then I've got all the components and everything coming to put it all together. So there was going to be another video anyway on doing the custom PCB design and how we translated this old mess of stuff into a single PCB board, but yeah, I guess we're going to have a whole other video now on using that, swapping it out, and then the final part of this will come after that, after we finally got it all together. Bit frustrating, but you know, that is how it is. It do be like that sometimes. If you have any idea why a single trace might be bleeding from 5 volts to 1 volt though, please tell me, because I would love to know. And it's nothing else is connected. I've checked all the traces alongside it of both the ground and the power, and neither of them are connected. So I don't know. Lovely to leave a video on such a low point, but at least we have a path forwards now, which is create the PCB. And now there's going to be the whole mess of problems of, have I used all the right capacitors and resistors and all that stuff? I guess we're going to find out at some point in the future. But at least now all the wiring's done and I can forget about that and put all my interior back together. So let's finish with that, and we'll come back in the next video and make some custom PCBs. If you like this kind of stuff and you want to see the end of this little journey, make sure you hit the sub, and if you enjoy feeling my pain with me, give it a little thumbs. Otherwise, whatever you do with the rest of your day, have a wicked one, and I'll see you in the next video. Take it easy, peeps. Bye bye.